what our experience has been so far is that it's actually quite good to write API tests even in the beginning, because it just helps you to move more quickly, because you can develop better APIs if you have the test. It's just like how to write quick code, that you are quicker if you already have the test instead of trying to manually test, say, APIs. That has been that using the test-driven development just in the beginning has proven to be quite beneficial, at least so far. But then that is usually when we are talking about APIs and the backend, and there it is like doable. You might like not even want to test everything with unit tests in the beginning, but you at least have the API tests. But then if you move forward and you have to test an web app or actual app, then it gets more complicated. And if you have the UI part in the game, then usually in the beginning you really don't want to do any tests, because it's changing so fast and so often, and the tests actually don't help you to develop quicker. The tests just help you to guard that you won't break stuff. But breaking stuff in the beginning, it's not that crucial, like you said, Anton, as well. And
yeah, exactly. So yeah, you described really good angle in doing, for example, APIs, covering them with like an end-to-end test. So it's, first of all, when you're writing an API test, then you're usually covering quite many layers in the system, and yeah, you kind of pointed out really well that it's not only a tool for ensuring quality, but it's also in a way something that helps you design the API. So it has lots of benefits besides quality assurance. So first of all, you think through what the API should look like, what you would like to see as a user, as a client, and the second part of it is kind of you're probably much more quicker to develop than kind of ongoingly manually test every change or that you're doing locally. So yeah, there is like great benefits in kind of covering this quickly. Yeah, and yeah, I didn't kind of emphasize the UI part. So actually, the place where we are finding ourselves today is like 3-4 years later after we kind of built the product. We were still not confident into starting to invest into the UI tests. So we're just starting out with it, and we're kind of writing the UI tests for the parts that we know that are stable. But it's like maybe just like a 20-30% of the whole system. So all the rest of it is like bound to change. Definitely is going to change. So it's a pretty big maintenance overhead that it already brings. But yeah, regarding the unit tests as well. So it's kind of again, it depends. So it's a matter of what are you unit testing. Is it some sort of a core module or core functionality that you know is going to kind of stay? Sure, it kind of it's like a reasonable investment to put in the time and cover it with all sorts of tests, or actually even kind of build it in a test-driven way so that you the function that you're building, it's also like providing an API, so you're kind of building it from outside in. So sure, put in the effort. It's kind of worth the time invested. The probably the prototypical parts are the ones where you're just playing around or experimenting with things. And those are the things where you can't actually confidently say that, yeah, this is going to kind of stay. So maybe you're kind of adjusting an algorithm. So in our case, for example, we're testing and adjusting the algorithm constantly of how do we kind of create matches between users and companies. So this is also like it's an ever-changing system. So if we would kind of cover it fully with the test to the kind of details, then it would become a quite heavy barrier for us to kind of think of it as evolving functionality. So in that way, it requires a bit of a critical thinking. Is the thing actually kind of will the test help you to ensure that things won't break, or will the tests get in your way?
I would imagine that when you're starting a startup, it would like make a lot of sense not to cover everything fully, because as you mentioned, you want to develop really quickly. But in my practice, I have seen a lot of you think that I'm not covering this with tests at the moment because this can really change and I need it fast, and I will do it later. But later, probably you will never do it. Like people really rarely write tests to code that has been there for like over a month or something like that. And also I think like it's really easy to think that, okay, I'm not writing too much tests because it makes refactoring really hard. You have to refactor the tests also. But I think it goes the other way around as well. Like it gives you the courage to actually refactor, because at the beginning there is a lot of refactoring, and if you really don't know if it will break something or not, that also creates issues. So the balance has to be considered really wisely. Yep.
And when you have considered the balance and actually like found out that all right, we will do like some tests, we'll skip some other tests, for example, for UI, but then the monitoring comes in, that if you have decided that it's not cost effective to do the tests, right now we need to focus on different things, then at least we should catch the problems that the users have. And here we have like many different practices. For example, with frontends, it's quite simple. You just include the Sentry using the Sentry service, and you will get all the problems that appear in the console of the browser. And you can catch them, you can see what is happening, because you cannot get the logs from the frontend that well into your logging system. But then for backend, we have some other policies present. And for example, Antti is one of the first ones who did the zero exception policy in our place. So maybe you can talk about that a bit.
It is what it is. Like we don't tolerate any exceptions. All the exceptions land in our Slack channel or on-call system, and they all have to be managed right away, like either solved or somehow excluded from the alert systems. But yeah, nothing. There is no like random exception in the log that no one is aware of. So that works quite nicely, because sometimes we catch stuff right at the moment they're happening. Like user has some error in the application, and he's not yet even contacted our service desk or something, but we already write to her that, okay, we saw that the exception happened and we will fix it right away.
These are like kind of like two types of approaches. When it comes to like, I don't know, unit testing, integration testing, we try to catch the issue before it happens, and with monitoring, we try to react to when it happens and resolve it as quickly as possible. Then, yes.
Do you have someone do you have some sort of a rotational system in your team, so that someone is always on call, who's monitoring that, or are those exceptions in the Slack channel so rare that you don't actually kind of need someone?
They sure could be more rare than they are, but yes, we have a rotation, and we also have a priority system. So not everything results in a phone call to on-call person, for example. Some exceptions are like, we know that they can happen and it is okay to fix them the next day, for example. So the exceptions are usually prioritized. But if something comes that is totally unexpected, then of course it will be handled right away.
Interesting topics that we have had in one of the projects is also about the pact, and that's also like a way how to do something like similar to testing and monitoring. So you proactively catch the problems that the compatibility of different APIs would not be a problem. What do you think of that, Indrek? And like, when would you start using pact? Would you use it for a startup that is starting today, or will you use it like after a year when you have a couple of services already present? Or what do you think about the contract-based testing approach?
Well, yeah, pact is a consumer-driven tool. The idea here is that when you have like several systems, let's say when you have like a backend and some front-end application, it could be like even a mobile application. You define the API contract between them, and this allows you to quickly verify whether the two participants in the contract, the mobile app and the backend, whether they like comply with the API. And you can do that without actually like doing the classical end-to-end test where you have to both set up the backend and the client of the backend. But now coming back to your question, whether when should this be done? I would say that having this kind of setup, it's easy to. This is something that gives you the feedback very quickly when you break the API. So let's say I'm working on the backend, changing something, and I can run those types of tests in isolation without having to start or without having to take out my phone and test it through the app. But then again, there's still like a cost of setting up this system. And when it comes to setting this system up like a year from now, it becomes even more difficult because this consumer-driven contract testing approach, in my opinion, gives you the most benefit when the entire system is covered with it. But if you don't do it entirely, it becomes like you can trust it a bit, but there are still some like places where you don't see whether the system actually catches those errors.
So I'm not. I haven't used this tool, but just to maybe dig a little bit deeper and understand the details. So you obviously you have like some sort of like a API, like a interface on the back end, and then on the front end you would need to set up your client in a way that this can also be validated that the interfaces match. Am I correct?
Essentially, yes. You can think of it as you have defined the API schema somewhere, and the system kind of can on the fly validate whether both the client and the server comply with this interface specification.
Okay, that's quite interesting. So maybe not as kind of fully automated approach, but this comes back to a little bit of this bringing in type safety as much as possible is, for example, GraphQL, using GraphQL instead of REST APIs. So GraphQL describes its interfaces, and it has like a pretty strict and good type system. So this is in a way like a really good tool to ensure that things cannot break. So it kind of provides you level of safety on top of the backend, so you cannot actually push some weird types where they're not expected, or like you can also like use enums instead of strings, things like that. So it kind of all fits together quite nicely. But of course, it doesn't ensure it doesn't bring the automation part as Pact would do, but those things would probably mix quite nicely. So you take the schema from the GraphQL, you take the query definitions on the front end, and then somehow kind of validate those things. But kind of even just using GraphQL because of the schema definitions and types is already a pretty big kind of layer of quality assurance in a way, whereas like using just really simple JSON-based payloads and using some sort of like a REST-ish APIs. So just wanted to comment on that.
I'd like to come back to the monitoring part a bit. Well, on the testing side, we have this heuristic that we can use on how that kind of like tells us how much we should put into, or how much effort should we put into different types of tests. Perhaps you have heard of the testing pyramid, which kind of states that you can think of it as a pyramid, which on the lower side of the pyramid, you have unit tests. In the middle, you have like some kind of integration tests. On the top, you have UI and end-to-end tests. And it kind of states that more effort should be put into unit tests because they're easier, cheaper, more specific. And then this is like a spectrum going up to the end-to-end tests where they are more, let's say, more expensive to maintain. But a question to you, Mikk, when it comes to monitoring, how do you see, where does monitoring fit into this approach, or does it even fit in there?
First of all, I think the pyramid itself is a bit like outdated conception. And I have seen like different new types of pyramids. And I think the monitoring is actually a part of the new age pyramid that you cannot write only tests and be confident. It's not possible, because you will have the kind of problems that you cannot just test it through. You don't see all the problems. You will have such a corner cases that are like impossible to see before they actually happen. And then your testing strategy should be built on that it's not possible to do everything with tests. And then the monitoring comes in, that you actually want to catch the problems as quickly as possible. And one part of it is actually like catching the problems quickly, but another thing is that you have to be able to fix the problems quickly as well. And then the processes of, for example, continuous deployment come in, that your software should be releasable at any time and really quickly. If you find a problem, maybe you write the bug fix in 15 minutes. But if your pipeline to production is half an hour, then you are losing time. But your users are already having some problem. Then it's like part of the testing strategy. Somewhat is also the pipeline length, that you want to be able to release in 5 minutes and not wait for 30 minutes. Because you already know that the strategy is that you will not invest too much time into testing, and you will not test the things that are really infrequent to happen. And then you rely on other practices.
How do you keep the pipeline short? Just an additional question. What's the approach? How to make sure that your pipeline doesn't run half an hour?
Well, you have to take a look at your pipeline, what is taking all the time. But for example, let's take a look at deploy. For example, the simple pipeline is that you at first run unit tests, then some integration tests, then maybe you deploy your code to staging environment, then maybe you run some endpoint tests, and then you, if everything is green, you will deploy to production. And then you have to take a look at each of the steps. For example, the deploy to staging step, that maybe it is taking just 5 minutes to deploy your code. And maybe it's because you have like inefficient rolling update strategy, and you could be more aggressive that you update like in a better way. And perhaps your application takes too long time to start up, and then you have to consider that maybe my technology is not a good fit for cloud, and I need to optimize. So my application will start up in a second and not in 50 seconds. And then coming back, you have to make sure that you don't have too many tests that take too long time, and then you have to balance between them. So the overall time will be as short as possible. There are many ways how to optimize that.
And I think
parallelism first of all, and like making sure that you don't have one long linear pipeline. So
surely breaking your service into like smaller deployable units is also helping a lot.
Yep, this is actually what we are going to talk about after a small break. Next we will have a discussion about microservices and about smaller pieces of deployable units. But now let's have a 5-minute break. You have a chance for networking, and let's continue in 5 minutes.
And in the tables, we can probably discuss the same topic as well. That, for example, like let's discuss how to write UI tests. Let's see if someone is actually writing them, and maybe you have good ideas how to do that.
Sounds good.
Yeah.
Hello, and now we are back. I hope you had some good discussion. Later on, we will have some more time for discussions, but now we will continue with our second half. And as a start, I will share a little bit about the app I promised you. So maybe you have heard about Super Agile. If you haven't yet, then I shared a link where you can download the free ebook where we write the 13 elements of Super Agile out quite in detail. If you saw in Remo, we had the names of the tables, and the names of the tables were actually those 13 elements and plus 5 of our values. But Balanced testing and microservices are actually two of the elements. So this is why we are talking about those things today. However, as I mentioned, for the whole Super Agile, we have created an app, which is again free, and you can download it and you can use it for your own development team retrospective. The retrospective, if you haven't done it before, it will probably take an hour and a half or sometimes even 2 hours. And it goes through all those 13 elements. And the main idea is that it brings out good discussions. How are things in your team currently and what you can do. This app we have now out is the real MVP. So probably there's a lot of things to still improve. You are always welcome to give us feedback, but just start play around with it. It's quite easy to use. It's similar to planning poker, and the idea is that you discuss the level of each element in your team currently until you reach a decision where you are today. And of course, then you can also come up with what to improve. And here is a small video which just briefly gives you an idea what this app is about. So yes, download it, try it out with your team, and give us feedback how it went. And hopefully you learn something and you find something to improve in your product development team. But now, as promised, we will continue with the second element of Super Agile, and this is microservices. And once again, I will ask the four great tech leads to come back to the stage. The floor is yours.
Okay. In our previous discussion, Antti mentioned we were talking about the speed of the pipelines and how to improve them, and Antti brought up like what if you have smaller deployable units and then each pipeline could be faster. And I think this is a very good segue to our current topic. Let's discuss microservices. Here in the software engineering industry, we hear a lot of talk about this architectural style. We have cloud services that provide managed platforms where we could build these types of architectures. But in the context of startups, what do you think, how good of a fit this type of approach is, like going full on with microservices from the beginning, or ignoring this route? What do you think?
Actually, I thought about this topic right before this event, and it was really interesting because I changed my mind quite many times. Like, my first instinct was to go with microservices because like this is what I usually do. I don't do a lot of startups maybe, but this is my habitat. I know I can do well with microservices, so this is what I would choose maybe. But then I thought it needs all kinds of infrastructure to be set up. It is harder to refactor stuff, and you don't actually know what your end product will look like. So maybe it's not a good idea to waste all this time to set all this environment up. And maybe like the monolith would be a lot quicker, and I can get stuff to production, and users can already use it, and I can validate my ideas. So then monolith seemed like a good idea. And then I thought, yeah, but at some point I would like to go with microservices again. So maybe I could try to write the monolith, but to keep things really separate. So it's like microservices inside the monolith. So this also sounded like a good idea, but then I started to think about how hard it is actually to do. Like how many monoliths have you seen where there are different parts of the monolith have different database, for example, or different database schema? Because it is really easy to make like database joins, and once you do that, it's really hard to actually break it down to microservices. So that made me think that maybe my initial idea of going with microservices is not so bad at all, because nowadays you can really use a lot of things as a service, like your container orchestration or database, and all this stuff is available for you in cloud. You can just it's a matter of configuration. It's not so hard to do this nowadays, I think. And also, if you have really like a good way to like a good skeleton where you can spin up new microservices really quickly and easily, maybe it's worth trying out. That's my ideas.
Anton, you previously mentioned that startups rarely fail because of like technical problems or technical issues. What's your take on like this?
Well, just to comment on this thought is also like it's not as if they fail from technical reasons, then probably it's not as obvious that you can pinpoint it. Obviously you could have like done something differently to be faster, and or maybe there are some kind of reliability issues that kind of start hampering the product. But like mainly it's not a technical issue. Probably they run out of money. that's the main issue. But so back to the microservices, it's a good question. It kind of like since Antti has everything like fleshed out in his head already and knows how to kind of set things up, and has the skeletons probably easily built, probably already from a command line, from all the scripts and toolings that he has built up over the years, then yeah, definitely it's really probably the way to go. So the decision point actually comes from what you can do, what's your experience, and all of those things. And if you have like lots of experience, you have probably solved already quite a lot of problems that come with microservices, and you're confident with it, then it's not a problem, I suppose. In our case, when we started MeetFrank, so I was the only developer, developed the first version of it, and so on. It took quite some time, because we were doing quite a lot of prototyping and redoing the product and all of those things as well. So in my case, it was so much easier to do everything in the same runtime, because there is just so much less things and problems to think about. So everything is kind of accessible, although you will be falling into a trap where you're using the SQL joins and all of those things. But at the same time, it also makes you maybe ship some features faster. Now, today, we're at a stage where we are like playing around with the idea that spinning off some parts of the system into or extracting them into a separate service or a microservice. But then there's like so many other priorities that it kind of always the question comes up: should we invest the time into kind of extracting something, like putting in the time and effort? And it's a pretty big challenge to do, especially if the things are coupled on a data layer level. So, but new things that are being built, we do use like we have a monorepo where parts of the system are already kind of built using AWS Lambdas, and so new things can be added on top of that easily.
Anton, I have a question. You mentioned that you are thinking about breaking out some things into microservices. What is the reason why you are even considering it? What is the end goal that you want to get from doing it?
So some there's always the biggest concern is you have in case of a monolith, there is always one big point of failure, which is a database. Like if you have a single database, then it at some point gets hard to scale or it gets like really expensive to scale. So some things that require much heavier loads could probably have their own purpose, have their own database that maybe is running on top of something that's actually purposely built for that. So it makes those decisions much more flexible. So you can kind of split the logic out on the data layer. That's the kind of one of the main motivations, because like the server side or the kind of the backend services themselves, they are fairly easy to scale. You can just horizontally kind of add as much nodes as you like, and everything works. But it's much trickier on the database level. So that's one of the primary motivations why this we're kind of playing around with this thought. The biggest hurdles that we see when we would imagine that everything is working using like in a microservice architecture. Maybe Antti can actually comment on that later. Is how much more difficult it is to kind of monitor, investigate, debug, and get to the root of the problems once they start happening, because like things are much more spread out. You have so many much more components and parts in the system, so it's not just like a stack trace that you're looking at anymore, but you actually need to kind of stitch bits and pieces probably together to have a look at. Or you need like really good tooling straight from the start.
I asked about like the why question, because we are in a similar situation that we are also breaking stuff out from big monolith into like a smaller microservices. But the why not that often is about the database for us, because so far with database we have the AWS managed databases, and you can, if you have the money, like you said as well, that the money can be a constraint. But if you have the money, then it's quite easy to scale the databases out quite well. And we have really big services on like one big database. For example, like Stack Overflow is like essentially like one big database. But so why for us, it comes usually like not in the really beginning, but when you have more developers working on the same software and the software grows. And in the previous talk, we also discussed that if the pipeline is taking more than 5 minutes, then you might have a problem. And usually if you have 10 guys working on a component, then it grows over the 5-minute limit quite fast. And then you like need to decide that whether I build the software even bigger and make it even slower. And if the component is slower, then it's like slower to actually fix the problems in production. It's probably slower to actually develop it locally, to run it locally. And this is all some kind of overhead. And it can be quite beneficial to like start optimizing it even in the beginnings, that you cross the 5-minute limit and you already in the beginning take some kind of cut and now consider that, okay, we need to do something a bit differently.
Yes, I just checked that our pipelines run roughly 10 minutes. So it's not a disaster, but it's kind of.
But that's good. 10 minutes is good.
it's more or less. Yeah. So yeah, the like as I mentioned previously, at the moment we have 6 people on our development team. So it's 3 backend engineers. I'm also kind of doing some backend tasks at times, and then there's 2 guys who are solely focused on front end. And as the team grows, I think that we will actually run into the same why question at some point, because there is just too many kind of elbows around the same code base, and you can't actually like, let's say you want to improve the monolith in a fundamental way. You want to actually refactor something that's like a core utility that touches the whole code base. This change alone will create quite a lot of like overhead. So and if you imagine that there is like not 3 people working, but let's say like 20 or even more, then I believe that I would like to hear like what are others' experiences, because we're not at this stage yet. But I imagine that this would kind of become quite a difficult problem. So refactoring as such will be like times more difficult. Whereas if you have a microservice, you can kind of go one by one, and everything kind of starts to run smoothly. So
well, yeah, I kind of see that this is a problem that a lot of teams in general will face when they scale up. Like lots of teams working on a single code base, and people start stepping on each other's toes, and perhaps even it becomes even more difficult to make releases, because everybody's at any point in time, somebody's in a state that like, wait 1 more hour, I have one thing to finish, and it's hard to find this sweet spot when the monolith is now releasable and now let's do it. But Anton, you had a question before as well, like when it comes to like finding out issues or debugging issues in a distributed environment, and
Yep. Obviously, it's solvable, but it's a question of like if we would need to, let's say we have an app idea and we have 2 days to like bash something together, then what would be the way to go? Okay, 2 days is like too short of a time, but let's say like 2 weeks. So what would be the way to go? Someone commented that you can use like distributed tracing and all of those toolings that you can they kind of solve those problems. What's the like the time overhead of setting up all of the tooling and needed things for the whole infrastructure? Whereas just building some like single server app and deploying it in a load balanced environment, and everything more or less works. If there's a problem, you kind of know where it happened.
Well, there is certainly an overhead, and I think it depends. Like, I think if you really want to push out something in 2 weeks, then probably the overhead is too big. But I think you can like estimate how easy it is. If you build a monolith for 2 weeks, it is quite easy to break it into microservices later. But if you do it for like half a year, then probably you already have a system big enough that the decoupling can prove more tricky. And actually, the decoupling at the later stage can take more time than the initial overhead of setting up this tooling for microservices, I think. But I really cannot say what is the like ideal balance, like how many days or something like that.
I think that if you have 2 weeks, then like the way to go is microservices, but you go with services that you don't build yourself. So for example, you don't build some like user pool and authentication yourself, but you use some service like Zero Auth or Cognito or some Google service instead. And you use other components as much as possible. And in some sense, these are your microservices at that time. You are just some kind of glue that puts everything together, and you write as minimal code as possible. And if you just have the 2 weeks, then we have like dedicated services. We have the AWS Amplify, we have Google Firebase, and these are the services that are meant for like really quick prototyping. And these services that are like built for the 2 week MVP, they kind of are built on microservices, that they are usually like function based, that you write some functions instead of like a big monolith. And then you will go with microservices from the start, actually. And later on, you have to think of how to get out of them, how to like start building your monolith, but to start with microservices, because that is actually the quicker way how to go if you only have 2 weeks.
That's actually a pretty good topic. So the Firebase and Amazon Amplify, obviously, it's like you just build a function. You have the like data storage, everything is there already. You probably have our push notification capabilities, etc. But how kind of sustainable is it in the long run? Do you have any long-term projects that have been built there, and the ones that haven't like stayed only at the 2 week level, but actually been developed like months or years even?
Our experience is that out of these two, actually like AWS Amplify is like more extendable, which means that if you go with Firebase, then you are a bit stuck, that it's difficult to build like other APIs together with Firebase. You just have the Firebase thing. But with AWS Amplify, you get the benefits that you actually don't have to deal with microservices in a way. It abstracts the infrastructure totally away from you, so you can start quite quickly. But later on, if you grow, then like the Amplify is just like glue around the AWS services. So you can like throw the Amplify away, but still everything works because it has like the GraphQL, it has some, for example, DynamoDB, it has the parts that are like actual components. It's not some kind of magic as much as Firebase is. And then it's possible for you to start really quickly, and then later on you can decide if you want to build like a dedicated infrastructure using Terraform, or you still want to use Amplify console. It's like different options, but it's but in the end it's just like managed services and some kind of glue.
Okay, that's a fair answer. I also imagine that AWS kind of it has so much more. They don't put a barrier around this one service. So what their motivation is that you kind of scale into the whole AWS stack as you grow. So yeah, that's quite interesting. Actually, one of the other quite big considerations usually for teams considering moving into microservices is local development environment. So how do you kind of solve this part? So yeah.
Usually, if we go with microservices, then locally you only run one service at a time. So if possible, we write locally like independent services, and we don't integrate anything locally. So you don't have to bring up environment of 20 microservices to run it locally, because you will build one service, you build the API, you write the API test locally, and you just you integrate based on the APIs in the staging environment. And that is like the fastest way how to move forward, because you don't have to test stuff out locally with many different services. We tried that approach like maybe 5 years ago when we started to have the first microservices. Then we had like an environment of 5 different services. We had to bring everything up. Later it grew to 10 services. Everything went running locally, but it was quite troublesome. That it was difficult to run. It consumed a lot of memory and so on. But now that we are like writing services in isolation, we actually have better API test coverage, because you cannot test it locally with other services. You have to write an API that is your contract. And the services itself, they are like really quick to spin up on their own as well. So in the end, you're using like locally is a real database. You're using, for example, Postgres in Docker, but the service itself, it runs without other services, but just everything else is mocked in an integration test.
Okay, and okay, and the stage where you're kind of need to develop things in a more integrated manner. Let's say you're actually developing a UI, or you're testing your service in a like you want to manually test your service in an integrated way. So you push it up just in a like a development environment in your cloud, and then basically work there. So
it's so actually, because for UI we don't push it up, because with UI you can run it locally with, for example, staging backends. So you can write code against staging. You can even write the code against production data. So for UIs, in our case, it's not usually the things that you have to like push it up to staging environment to actually integrate with other components. With UI, it's a bit more simple.
Yep. But where I was leading with my question is, let's say you have several teams and maybe like already significant amount of developers on the teams. So does each one of them have their own how are the development or staging environments set up in the cloud in that case? Let's say you're working on something, I'm working on something, and we need to test things in isolation or separately in the staging environment. And
usually we don't do like simultaneous releases. So if we have two components that have to go to production, we don't like put them to production at the same time. We usually like do the first one, build the API locally, we push it up all the way to the production, and then the second component can come and it can integrate to the first one.
Which kind of brings to the trunk-based development. So you need to kind of follow that practice as well, so in order to things actually run smoothly. Otherwise, like I imagine if you wouldn't have like trunk-based development, but like longer release branches, then you would also need to probably run like tens of staging environments in parallel.
Yes, that would be more complicated. But if you have such a complicated environment, then I guess like the first step is to consider that maybe you can simplify it. Maybe like try to do it in a different way. But I think the pact that Indrek talked about can help in such an environment as well. That if you have like 10 different staging environments, then it can actually show you the matrix of like which APIs can fit together and which ones not.
Okay.
But okay, I think we are a bit over time actually. Now we can go back to the tables, and we have time left to continue any discussion we would like to. A bit of time for networking.
Thank you.
Thank you.
Thank you, guys.
Been a pleasure. Thank you.